Hello and welcome to a video all about polymers. This is the final part of the organic chemistry topic for triple in the AQA specification. We're going to be covering today, start off with what is a polymer, just to recap that. You would have learned that prior to this, but just recap it. Then we're going to talk a bit about addition polymerization, then condensation polymerization, and then we're going to just finish off with what we call natural polymers, but this isn't a great bit of detail. You need to know about that just a little bit. So, first of all, what is a polymer? A polymer is a long chain of repeating monomers. So, a monomer means one of them, and poly means many, so we have lots of them. A good example is like polyethene or polyester, where you've taken an ethene or an ester. Ethene is the monomer, and you've replicated it over and over again. It's the same thing occurring throughout in long chains, and that becomes a polymer. Now remember, when we have some maths in here, we have n, and n is any integer. That's terrible spelling. Let's try that again. Any integer, and it can effectively be as long or as short as possible. We don't know how long the polymer is, so we just denote n because it's just saying, look, it's a very, very long chain. And you can get synthetic or natural polymers. Synthetic are things like polyethene, because it's a plastic, whereas natural are things such as starch or cellulose, but we'll cover into those later on. So that was just a quick recap on what polymers are. Now let's look at addition polymerization, because we need to understand how we make a polymer. Now addition is is more simple, which is adding things together, and this one is we have things like ethene being the monomer, and that goes to form polyethene. That's the polymer. So monomer, and polymer. So ethene. Ethene looks a bit like this. As you have learned throughout the topic, it will have a double bond. Now I'm going to put an N here because we don't know how many we've got. We've just got a load of them. Loads of them. So we just put N to denote a large amount of them. Now what happens is this double bond here, we learned about double bonds are brilliant, it will split, okay, and we'll end up with something that looks a bit like this. It's become a single bond now. We have the hydrogen still in the same place, but this time that double bond is split. Now half of it has gone that way, half of it's gone that way. So half of it's joined up with another one of these, this side, and half of it's joined up with another one of these, that side. But we don't need to draw the whole chain, because as chemists we like to be lazy, we like to make things as simple as possible. We draw it like this. Now the final step is we put brackets around it, because this is saying this is the monomer and it is repeated outside of the brackets, but I'm not going to draw all the repetitions because I haven't got time for that. Then the final step is we put an N here just to say however many were here are now in this pattern. So if we were to draw this out, it would look a bit like this. You don't have to do this for exams. It's just so you get an understanding. And we'll just have hydrogen, hydrogen. As you can see, it's a very long chain. And it goes on, and on, and on, and on, and on, for however many ends. So instead of drawing it like that, we draw it like this with the bracket, because it makes life a lot easier. And it's clear and concise, and it's showing you exactly what's going on. This is a repeating unit over and over again. Right, let's have another example. Okay. Another example will be, we'll do it in red just so it's clear, but we're going to put some different elements in just to see how it looks. Okay, same process, but this time we've just got some slightly different ones instead of hydrogen. Oh, forgot the N. So this time, same thing, the carbons, the single bond, the double bonds split, one goes either side, which extends beyond the bracket. I don't want to see in any exams you drawing it like this, with a tiny little bit going over the bracket. Okay, I want to see you extending it quite a bit. I want you to make it extremely clear to the examiner that this line is extending beyond the bracket. Don't give the examiners an inch, make sure it's extending beyond the bracket. So then the final bit is, now this Cl will go here, this bromine will go here, this fluorine will go here, and this hydrogen will go here. So it's exactly the same, but this time we've got chlorine, bromine, and fluorine. Then the final steps, we put the bracket, and as I was just saying, it's clear that the line extends beyond the bracket, and the final step, N. This is another polymer. I don't know what the polymer is off the top of my head, I could probably figure it out quickly, but for now it's just a polymer, and you've got the lines extending beyond saying that this continues again and again, and you've also got N saying we have an infinite number, well, we have however many we had on the left hand side. So this is what we call an addition polymerization. We are adding to this double bond and we're making a long chain. So that is addition. Now let's talk about condensation polymerization. This one is a bit more complex. Nothing you won't be able to understand, but it just takes a little bit more thinking about. So condensation, when we think of condensation, we think of water, and that is key because water is produced. So condensation, polymerization, H2O is produced. That is important. Now, condensation polymerization occurs between what we call diols and dicarboxylic acids. A diol is a double alcohol, and a dicarboxylic acid is a double carboxylic acid. Okay, so what we will have for a diol, for a double alcohol, you'll have OH that side, then you'll have your carbon chain. Now I'm going to denote this carbon chain with a box. You're allowed to do that in your exams. This, we'll just say this box could mean, so this box in this example equals C, we have two hydrogens, instead of drawing this carbon chain out every single time, instead of putting it here, we can just put a box because this is not being affected by the condensation polymerization. This is going to stay the same throughout. So instead, we put the box. It just makes everyone's life a little simpler. So draw a box because these are what we call the functional groups, the alcohol group, the functional part. That is what's being manipulated in this to produce a polymer and water being produced. So this is what we call a diol, and a dicarboxylic acid is just two dicarboxylic acids. Same again, we can have a box to denote the carbon chain, and it goes to COOH. That is the functional group of the carboxylic acid. Okay, so remember the carboxylic acid was a carbon, we had a double bond to an O, like this. Well, we can write it as COOH. That allows us to just get a little bit simpler, and then we can start to look at it and understand how we're going to end up forming some water given off. So, if we draw it out next to each other, let's draw this out next to each other so it just makes it a little easier. Do a different colour. So if we look here, we need to make some H2O. Now we can circle around this hydrogen, and we can circle around here. As you can see, H2O. This is going to come off, and we're going to form a bond between the oxygen here and the carbon here. And this will allow us to make a condensation polymerization reaction as well as water being given off. So in the end it will look like, draw an arrow down to show you what it will look like at the end. We'll have the HO this side. It will go to the O here. But then this hydrogen's gone, so that's H there. Now we've got this side. Oh, let's do a green bond so you can see where the bond is. And then this H comes off, and this O comes off, and we've made H2O, water. So as you can see, we have created a polymer. Well, at the moment it's a dimer because we've just got two of these. This one over here would bond with another dicarboxylic acid, and this one over here would bond with another diol, and that's how we would get our polymer. It will be a repeating unit over and over and over again, where it will go diol, dicarboxylic acid, diol, dicarboxylic acid, diol, dicarboxylic acid, over and over again in a very long pattern. And again, N will be coming off, but this time it would be, we'll put N there, and next to the water we'll put 2N, because you get two sets of water coming off. You'd get a water here, and you get a water this side. Two lots of water for every single one of these. So this is just looking at how we can make a condensation polymerization. And what you need to understand is the basic principles by reference to the functional group. These are the functional groups, and the idea is that water is given off, and you make this bond here, which is then here as well, it's here, and it keeps going on and on and on. So this is condensation polymerization. Water is given off, and it is between a diol and dicarboxylic acids. They can be any diol. It could be diethanol or diethanoic acid. It could be diheptanoic acid, dodecanoic acid, whatever you want. But remember, as I said, we can put the box in there because we're not changing the carbon chain. It is just the functional group that we're focusing on. Right, and that's finally, let's talk a little bit about natural polymers. So, natural polymers. We have got amino acids. They are our monomers. And when they join together, they make proteins. They are our polymer. You don't need to go into a lot of detail about them. You just need to appreciate that amino acids are the monomers, proteins are the polymers. They work by condensation, polymerization. Water is given off. Another natural polymer is DNA. We have two polymer chains, and they are in a double helix formation. You all know what DNA looks like. If you don't, Google it and you'll see what I mean by two polymer chains in the double helix formation. There are other ones which are starch and cellulose in plants. These are our polymers. The monomer of starch and sometimes cellulose, I'm not quite 100% sure on what makes up cellulose. I think it is this, but definitely the monomer of starch is glucose. Lots of glucose molecules coming together makes a starch molecule. This is our monomer. and then these are our polymers. There are other sugars which are monomers. We got fructose, lactose, loads of different ones. Okay, so these come together, and sometimes you have glucose and fructose, or sometimes you have glucose and lactose, or fructose and lactose. You can have them coming together and you'll make a different type of sugar. There are different sugars, no, sorry, different starches or different polymers. So the common sugar that you have is glucose, but you might find other ones as well. So glucose as a monomer comes together and makes the polymer of starch. Cellulose is also another polymer. So these are your natural polymers. You don't need to go into a massive amount of detail about it. You just need to appreciate. And furthermore, these also go via a condensation polymerization. It seems to be addition polymerization is mainly, not always, but mainly for synthetic. So, I hope that helps with polymers. Thank you very much for listening.